whenever you're ready, Ryan.
All right, sounds good. Glad I wasn't late. I was just trying to make tea and water just didn't boil fast enough. All right, so a couple of highlights. Two new committer announcements. So one isn't on here. I don't think it's made it to the list yet, but the account's already created, so I'm going to go ahead and jump the gun. So first new committer is Brian Keller, who's at Netflix and has done a ton of work on the Kafka Connect sync. Brian's been committing to the project for years, actually. I mean, if you go back and look through his contributions, it's like, oh wow, that's quite a bit. So he did the original rewrite metadata and things like that. So that is fantastic. It's great to have Brian in the community, and really glad to see him, as a committer. The second new committer is Renjie, who has been contributing to the Rust implementation. He's been, by far the most active person on the Rust implementation. Has just been like doing an awesome job, and so like huge thanks to Renjie for really putting in a lot of time and effort to make the Rust implementation a great thing. So welcome to the new committers. Really great to have them. Next, I want to highlight the Iceberg Summit 2024 that's coming up. Thanks to JB. It should say thanks JB there. I like to thank people here, so thanks JB. Thanks to JB for help, getting the proposal put together, really pushing that through. The call for proposals is up, and the summit is going to be May 14th and 15th. So please, please, please submit talks. We'd really love to have talks on, the new implementations and status, technical details that we're looking at, like changes to the REST spec or things like that, as well as use cases, success stories, and just general educational materials. We really want this to be an opportunity for the community to learn a lot. I would also say, one of the things that's happening in this community is we're moving from a set of platform developers to a set of users. So at this sort of inflection point, I think it's really important for us to get out content about how we do things and how we do things well with Iceberg. That educational content is super important. So really looking forward to seeing all of that, all of the papers, proposals that get submitted. That's going to be open for, I think, 6 weeks, 5 weeks, something like that. April 24th, I want to say.
5, I think. Right?
Yeah.
5 weeks altogether.
Yeah. Oh, sorry, until April 12th, 2024. Yeah. That's right. That's where I got the 24. Okay. Next up, there have been a few highlights to go through. We added DataFile and DeleteFiles to the REST spec, so big thanks to Drew. This is going to be helpful for both the append commit route as well as the new route to do job planning on the server side. We will need to exchange data files in both cases, and for planning that comes back, send delete files as well. So that's a really good thing. Next, thanks to Rahil, also from AWS, for adding pagination. I think we're still tweaking the definition slightly, but it is really good to have pagination in there for use cases where you have, say, 1,000 tables or 1,000 namespaces. Those things do come up, and so rather than users being kind of bummed that they ran that show namespaces or show tables command, really good to have that in there. Next, I want to thank JB again for working through adding view support to the JDBC catalog. We thought it was really important, and even held off getting a release candidate out because we really wanted to see that at least one of the catalogs, non-REST catalogs, had support for this, and this sort of gets an end-to-end. Even if you're using REST, you need some backend for that REST catalog with the current image. So, this adds a very good option. Another one is I want to thank Gidon for pushing on the encryption stuff. We recently added EncryptingFileIO, which adds a few new methods to FileIO, which are basically new input file for a data file, for a manifest file, and for a delete file. What that allows us to do is basically make encryption a bit more transparent and stop people from editing that block of code in Spark that actually needs to run things in bulk and so on, but also really pushes forward the encryption support. So thanks, Gidon, for pushing that. And then lastly, I want to mention a quick fix to the snapshot log with replace table. Replace table previously would accidentally clear the snapshot history of the table. So even though we kept all the older snapshots, you wouldn't actually see that at a given time a particular snapshot was current. So really great to see that behavior fixed. So thank you, Eduard. Next up, I want to highlight that there is an RC5. Is that correct? RC5 for RC6. All right. So there's an RC6 on Iceberg 1.5.0. Please definitely go take a look at that. Yeah, please go take a look at that. There are a few known issues with it. So first of all, Spark's show tables command in V1 will show both tables and view identifiers. In V2, we've added a show views command, but the Spark implementation of show tables ignores V2 views. It just doesn't union those names across the listings. So that is something that we could potentially fix in Iceberg by hijacking the show tables command. It seems like something that we probably want to address eventually, but I didn't think it was a blocker for the actual release. Similarly, another thing that I don't think is a blocker is we've discovered that the InMemoryCatalog has bad listing behavior. So if you just say list tables with an empty namespace, it'll list everything, not just the tables in the empty namespace. And so we think that is incorrect and intend to fix it, but probably since it's an existing bug, doesn't need to be blocking the 1.5 release. And then the last thing I want to point out is that this release has, oh, it's not the only catalog with that behavior. Okay, well, we need to get that in catalog tests to standardize that behavior and make sure we're all on the same page. Yeah, so the other thing that we hit was in the REST spec, we've hit a couple problems where now that we have view support in the REST spec, how do we actually turn that off or on? Because as many of you probably know with your own REST catalog implementations, if you have one REST endpoint that supports views and one that doesn't, you can get some odd behavior. So I hit a bug where if the rule hit first to load views instead of tables, views for a catalog that did not support views would actually blow up the whole thing. So you basically had some queries that could not be resolved because the catalog throws an exception when you just try to see if something is a view. And that's a pretty big problem. So later on, if we have time after discussing materialized views, I'd love to talk about REST capabilities and how we want to add sets of capabilities to the REST catalog. This is not an urgent topic, so I think we'll get to the materialized views discussion first. All right. Yeah, next up, I think it's time to go into the materialized views discussion. So last time we were here, we said everyone take a look at Jan's proposal, and take a look. We'll discuss it this time. There was a lot of of discussion, like a lot of discussion. I saw, before I even caught up with the thread, I think there was one proposal with 3 options, another proposal with 5 options. There was yet another proposal with 6 options, and I think the last message I viewed on the list was 7 options. There was like some discussion around like voting and things like that. So I want to first have a bit of a meta conversation about like hopefully how we can move forward, because from my perspective, I think there was just a lot of confusion where we were not on the same page. Like we weren't talking about the same options, and every time we tried to talk about the same options, it was either here's a new list of options that I think is better than the old list of options, and then we weren't really talking about the same. Or like I also saw just not enough questions, and we tended to ask questions like, well, what do you mean by this, and then move on and assume that we knew. So I think the goal today is to try and get as many of us as possible on the same page about what are we talking about, and what's the decision tree for looking at materialized views. I think that it's really, really important for us to be speaking the same language on this and talking about the same things, or else we're just going to swirl around and never come to a conclusion. So I think that the first topic is that everyone kind of assumed, and this certainly like the implementations of materialized views out there assumed that a materialized view are 2 completely separate objects: a table that holds data that has been materialized and a view, and they have certain metadata to point at one another. Now, Jack came up with, Jack was looking at this and said, hey, we don't have to do it that way necessarily, right? So Jack, can you go over like why you think there's value in doing it differently, first of all?
I think it's in general the statement about materialized view is a view and a table, right? What do we mean by that? Because when you say a view and table, do you mean that there are 2 different entries of a view and a table in a catalog? Is that what you mean here?
So I think it is. So let's just say, for the sake of argument, yes. Now, I know that there are concerns about should you be able to directly access the table, like should that show up in a namespace or something like that. And to that, I don't think that we need to answer that question yet, right? Whether the storage tables are directly exposed. But I think that we have lots of options there to do things like names that are like namespace.view.materialized_table or like something addressable. The main thing though is that if those tables are real tables, then everything works on them, right? So your snapshot cleanup tends to continue to work for it, and things like that. Whereas if we change how those things are linked in through the catalog, then we would also need to change those things, right? So I think to make that more concrete, the original proposal said, hey, we'll add a table metadata pointer to the metadata of view, which I think means we need to track down any view that actually has a table pointer and have special handling and do things differently. So that seems more complicated to me. And I'm wondering, like, you know, what is the value of complicating that, like, separate table object, separate view object situation that you're trying to tackle, Jack?
Yeah, I think there are a few different angles to this, but the first one is after reading Young's doc, seems like one consensus that everyone was making the doc is that there is one single object. I think we're
Hey,
discussing
sorry,
one
Ed,
single view.
can you please not list options? Let's we want to, like, I don't want another set of options popping up. I just want to discuss, you know, sort of like through, if that's all right. Sorry to interrupt you, Jack.
Yeah, no problem. Yeah, I think one consensus people seems to be making in Young's doc is that there has to be one single object, and we do not want to expose the storage table, because in the very original, I mean, this design doc has been floating for quite some time, and in the original version, I think we were already kind of moving towards the approach you were talking about, which is you have a view and there's a pointer to a table identifier, and that points to another table, and it is the catalog's responsibility to rather hide the table or do whatever tricks, right? And then it seems like the discussion of multiple people there oriented towards the other approach, which is to not do that. That is why there are lots of other options came up, which is, for example, putting the metadata location file in the view spec, etc., which I start to have different opinions about. So that is from just the previous conversations so far.
Okay, so the value is, like, the primary value is not exposing the materialized views table through the catalog. And why is that important? Because, like, I actually have a very different take on that. So why is that important?
I think first of all that was kind of my conclusion from when I was reading the doc, and also when I reflect to, for example, me interacting with like catalog services, it is kind of a headache to have that because you it is a separate table, and you have to consider all the aspects about protecting the table and hiding it from the users, different life cycles, different things about that. And when we look into kind of, I think this is the implementation of the Hive view, and this is implementation of the Trino view, which is kind of originated from the Hive view. But for kind of all the other solutions, it is a single object. And when we look into the other options, the single object approach seems to be not too complicated if we implement that. When we look into the Java APIs, like how we do those maintenance against the underlying storage table part of the materialized view, seems like it is mostly just wrapping the existing APIs, and not that a lot of new complexity that we are introducing. So that is kind of how it is landed what it is today.
Okay, Dan, do you want to go?
Yeah, I raised my hand a little earlier, kind of while this discussion was still swirling. I think we kind of got to the right level, which is the question of, like, does it need to be represented as a single object, or can it be represented as two separate things, a table and a view, or some combined representation that is abstracting the table and the view portion of it? And I would say a lot of the arguments that I'm hearing are actually things that exist in either one of those situations. Like, you still have life cycle, you still have, like, well, how do you protect the data? All those things still exist. They take different forms. So I'm interested in, like, well, what are, like, the core things that have to be done that you can do in one versus the other? So for the combined view, view storage table approach, where you're abstracting that, you know, what are the key from like an implementation standpoint, or like from a, I guess more from a conceptual standpoint, like what is that offering that having a view and table that are both referenceable and separate under the current definitions of view and table, like what distinctly does that provide? Like life cycle of table, they exist for both. Like you still have to maintain it. You still have to protect both. You know, that doesn't actually change. Just because it's a little harder to get to or it's represented in a different way doesn't mean that it's actually protected. So it's kind of this question of like, okay, well, what does that new representation actually provide?
I mean, it is basically a little bit harder aspect, right? You have a separate table, which is a little bit harder to protect, and also a little bit more steps to access the table when you access the view. It is kind of this a little bit more complexity part that could be simplified if we go with the other way, but
I don't agree that this is the simpler option. Like, I think the simplest option is to add add just a little metadata. I think it's actually far more complicated if we go this route where there's some combined object. I mean, like, I get that, like, you have to protect the table and the view, but you know, if you're implementing a access control system, why wouldn't you just give the table the same permissions as the view and call it a day? Why do we need different, you know, essentially different ways of interacting?
so as I was looking at the comments, do we want to address the comments or keep talking? Or what do you want to speak directly?
Yeah, so I was just stating on the comments that the choice of whether to expose the storage table or not, I think it's a separate choice from whether it's a combined or separate object. So we could have an implementation where some namespaces, which we dedicate to the storage tables, don't show up in table listings, for example, from the engine like show table command. So you could choose always to hide those patterns and then still go with the separate objects for views and tables.
But the question is, do we want to, is that a part of the spec? Then are we enforcing the names, kind of this kind of convention, some sort of spec?
You could delegate it to the catalog. So the spec can avoid taking a position there, but then catalog implementations can say, hey, like I'm gonna show tables with this pattern and not with that pattern. And then maybe like view storage tables can follow the pattern that's not showing up in table listings according to the catalog implementation. And again, the spec doesn't have to take a position on that.
But again, like stepping up one level, like this is true for both of the implementations. Like you still, even if you were going to combine the view implementation, you need access to that underlying table. Like Spark will need a way to read it in order to satisfy a query. You'll need a way to get the maintenance procedures to act on that table, because, you know, storage tables will still need, you know, snapshot cleanup and all of the things that you have to do from a maintenance perspective. That exists in both cases.
Yeah, but that is derived from that single thing, right? That single materialized view, rather than it is like somehow two objects synchronized in some ways that the catalog has to provide more capabilities. I think I'm just in general worried that we are talking a lot of things about, yeah, let the catalog support that. Then what's the point of having like a Iceberg view? Because I can literally just say, like a table, like in the view, have a view property saying that this points to a table, and that's it, right? Then
Yeah,
I add snapshots summaries or I can already add random snapshot summaries. Then, like, what's the value of having like an Iceberg concept of materialized view in that case?
So the value in that case is standardizing how materialized views are represented, so that when Trino loads a view, it can go use a materialized representation, and when Spark loads the view, it can use a materialized representation. Now, this would also support multiple materialized tables if it's not one combined object, without getting crazy about, like, you know, commits tied together and things like that. And I would also add that if we combine these objects, so you are forced to load them, then we're adding complexity, because, you know, when we load a view, we've also got to inject the table into the view plan, right? So we just added view resolution in Spark. What we do is we parse the SQL, put it in the plan, and then we run more rules on it. Well, I would also, in the rule where I have just substituted the Spark plan for the unresolved view, or sorry, unresolved relation, I would also have to go resolve certain relation, or, you know, I would have to determine at that point whether I'm swapping in a view or whether I'm swapping in a table. And that's like not the right time. So like, I think it actually makes that logic more complicated.
My understanding is when we suppose we do the materialized view work, like how is that going to interact with the analyzer? It should be always like you resolve it as a materialized view first, and you check if it is stale. If it is not, it is stale. If it is stale, then then you resolve it as a view. If it is not stale, then you resolve it as a table, right? So you kind of have to always add that logic. And right,
So
it's not like with current view integration, it is going to work.
No, you don't have to do those at the same time, right? You can substitute in the view, right? And then later in a rule, go say, hey, do I have a materialized view under this point, and swap. I mean, I'm just saying, like, this would dictate how these things get resolved, and I'm not convinced that it's actually simpler than what would happen otherwise. Sorry, Jan, you've been waiting patiently for a long time.
Yeah, no problem. My question would be, what would be so much more complicated if we do it with two objects? Because I think like Jack's proposal kind of moved a lot of the complexity to the catalog layer. So at the bottom, you have the metadata related to view and the table, and then in between you have the catalog. And with the initial proposal with two distinct objects, you have two different identifiers, one for the view and one for the table. And I think with Jack's proposal, you just at the catalog level, you have one identifier, which then the catalog decides, okay, I'm going to use, maybe I'm going to load the view metadata, or if I'm using a load table, I can use the same identifier to use the table metadata. It's just that the catalog has more information. If you have two distinct objects in the catalog, one for the view and one for the storage table, if you're not careful, you could just insert some entries into the storage table, which is not related in any way to the view definition, and the catalog doesn't really have information about if that's a storage table or not. With Jack's proposal, where you have the view and the storage table in the same catalog entry, the catalog actually knows, okay, that's a storage table, and it's easier to prohibit the insertion of data, maybe, or also the listing. It's easier because the catalog has the information, I think.
I actually disagree with that. I think either way, the catalog has information about whether a table is a materialized views table, because the table has metadata that says, hey, I'm a materialized version of this other view. And it has information about the source tables and the snapshots of those source tables. Like, that's exactly the kind of information we're talking about putting in those tables. And so I think that either way, that table does have tracking information.
I would,
but we also, like, you don't necessarily have any of those problems, right? Like it's up to the catalog whether to expose those tables, and there are good use cases for it, like orphan file cleanup, regular snapshot maintenance, compaction operations and optimization on the materialized table. Like all of those things, why would you not want those running on the table?
I would just add that like I agree with what you're saying. Like you want to be able to do those things and protect that table. That's not the right mechanism to go about it, right? I think because you have to expose that still to the engines in a way to do those operations to refresh the table. And you don't necessarily have, depending on what ecosystem you're running in, like Spark, the ability to really protect those things. So you're kind of saying, well, let's create this obfuscation, which creates some amount of maybe safety for certain things, but people still need to be able to reach around and do things like the refresh operation and maintenance and everything else. So it's kind of adding a lot of complexity to address a problem that should be addressed a different way, which is actual like access controls on the table that the catalog can enforce. And that's a different mechanism entirely and outside of the scope of what we think of for materialized views. But I would think that the approach to securing that or addressing those kind of things is different than the representation.
One thing I would like to say is that you're saying that you're losing all of this, or like this functionality about snapshot cleanup and everything like that. But I would say that the great thing about the API at the moment is that if you load the table, you're dealing with the entire metadata object. But the great thing about doing updates is that typically you only do partial updates. You're adding a snapshot or you're rewriting the snapshot. You're not concerned with the rest of the metadata. And I think with Jack's approach, you could even use exactly the same API if you would do update table, and then you use the identifier of the materialized view, which is the same for kind of the view metadata or the table metadata. You could use exactly the same operation with Jack's proposal. I just wanted to like to mention it. I think you don't lose anything.
We could, but it's so much more complicated. I don't see value in, doing that. It's so much more complicated to do it that way, to say like we're combining these two things that operate independently and already have implementations that work perfectly well today. Like, why would we combine those things so that their commits are tied together, or you have to load them at the same time, or like I just don't see any value in it. And that's why I keep coming back to like, what's the problem we're trying to solve? And when I look at the problems that we're trying to solve, I agree with Dan, which is that I think you can build it either way in both scenarios. So I don't think that we're actually clearing that hurdle of needing the additional complexity. And I also think that there are strong arguments against exactly what is being proposed. Like, I would actually want to be able to build a system in which the materialized tables are directly exposed as tables, so that you can go directly to a materialized table, right, and reference that and read from it directly without doing the consistency checks, right? Like if you read from the table, you get whatever is materialized in the table. If you read from the view, then we go check and make sure the staleness is satisfied. But like, I see value in that, and I wouldn't want to preclude implementations from actually doing those things, especially if we don't need to, and we don't need to have this like new object or additional complexity in the specification. Now, I should mention that there's a difference between create materialized view and what we want to do on the DDL side, and how that bakes down into actual catalog objects that you interact with.
One more thing, I think Trino, they initially had two objects, both in the catalog, and now they moved to just one object and a reference to the metadata. So they had some reasons which led to them removing this option. I don't know the reason behind it. And if you like generally think about it, I know it's much more effort and also more difficult. But if you think about it, you also have to do 2 queries to the catalog, which has to do indexing, and it's more complicated. If you could fetch just one object once, it would like generally it's less effort. So I think if you wouldn't like if implementation time is not a matter, I think having one object is like generally the better option.
So in terms of like sending metadata, you know, we want the catalog to have options for caching, for avoiding additional fetches and things like that. You know, like I said on the mailing list, I think that is a separate concern because we can easily have a separate view and table object and send back with the view object, you know, hey, I went ahead and loaded the table metadata for your materialized views. Like we can do that in the API. While so like, you know, REST can give that good experience while keeping the remainder of the catalogs, you know, just essentially simple. We wouldn't need a materialized view catalog, you know, any of that machinery. So I think I don't necessarily agree with that argument that this gives us fewer API calls. I think we can achieve the same result otherwise. Sorry, JB.
Yeah, I think there are two topics in the discussion. Exactly what you said, Ryan. We have a discussion about catalog, the way it can be handled extra, but for me, it's a separate discussion. It's not related to the way we do materials view. The question that I have is the current way it's implemented. Do we miss some user use cases, or is it just complexity aside? Is it something that we cannot do at the moment? Or it's just a question of simplifying or getting the metadata in a different way? Because for me, the most important is what the users are expecting. I mean, if we are able to implement materials view the way it's expected, that's all right, in my opinion.
So I think seems like because I see a recurring argument is that, for example, for the 2 calls to get the metadata, since like we are talking about catalog can do the caching, and for there are 2 objects, the catalog can do whatever hiding that can do. I feel we are putting a lot of responsibility to the catalogs, and I'm not sure if that is the right thing. I mean, of course, I have a strong relationship with the catalog service, so maybe that is a good thing for me. But that feels like we are kind of pushing people to use a more complex catalog in the end, and this could be a problem that is solved at the spec level with a very low requirement for the catalog.
I actually take the complete opposite stance, which is that if we implement materialized views with table and view metadata additional properties, right, then that is 0 additional complexity on existing catalogs, right? We can build it and it'll all just work today with the existing catalog APIs. If we either change the way metadata is handled so that when I load a view, I also then have to go, you know, open a data file, like open a file in some location and get a file IO for it and like combine that, then the catalog implementation actually needs to change. Now, what I'm saying with the catalog argument is that we have the ability to put extensions into the REST protocol optionally to make that easier, right? If we decide that, hey, loading a view and then following that link and loading the table is too expensive, we can make it possible for the catalog to return both metadata objects at once. And it's up to the catalog to decide whether that's good. And that means like everything is just simpler. Yeah.
Yeah, so the other thing that I'd mention is kind of gets to JB's question is, in terms of what users expect, and I think like what kind of problems we can solve with this, if we take a really opinionated and narrow approach about how we structure materialized views, how they're represented, that actually limits what people can do with them and how they can use them, how they can address them. And if we bake all of those things like, hey, is it visible, is it not visible into the spec, that kind of precludes other use cases like what Brian said of, hey, maybe I want to hit the storage table even though it may be outside of its freshness guarantees or requirements. Those are things that I don't think we want to take strong opinions on. And sure, we may be able to work around those and make this new approach act the same as if you had gone with like a separate stage, like provide all the access to the tables, like all those kind of things. But it's almost like we're creating a new construct and then going through everything and unraveling everything we did to create that and protect it. And at the end, we end up with all the same capabilities, but a new representation with additional complexity. So I feel like this provides the most flexibility for people to kind of come up with new implementations or represent the storage differently or manage that in the way that makes sense for them. And the more opinionated we get about that, the less opportunity there is there. I also just want to quickly touch on Jan's point. I'm confused about the comment about Trino because looking at their materialized view definition, it looks actually more like what we're talking about because they have a materialized view, which is a view with the additional parameter of a storage table that they reference via their catalog identifier or catalog schema table name reference and a grace period. So that's actually very similar, I think, to what we're talking about. It's just they may have taken the approach, like the opinionated approach, is saying, hey, we're going to hide these things from users, and that's great. Like that's one of the options that we want to make available. And Trino definitely leans towards an opinionated approach to doing things, but I don't think it precludes being able to do the opposite, like exposing those things.
I think they had a PR recently, just a couple of weeks ago, where they have a flag. So they still support the old table with the 2 identifiers, but they have the flag where you can decide which one you want to have, and by default now they're using the metadata location. So the storage table is not listed in the catalog. I think some people commented this in the document, and I also asked on Slack in the Trino community.
That might make sense if they are trying to hide this without an ability to change a catalog, right? So that is definitely something that might be a concern, but I wouldn't necessarily take that as a direction that we should go. Xian?
Yeah, no, I just wanted to say, yeah, I think I see your point that even if you do address it by catalog, you can have different catalog implementations do access control and all that. But isn't that something we want to standardize as well, across catalogs? For example, metadata tables, there's a certain way across all catalogs to access that. I think if you just leave everything to catalog, it seems like it's going to cause a lot more confusion, I guess, when people switch catalogs. So I think there should be some standard as well, right? Whether we want to access views via catalog or storage tables via catalogs, if so, how, things like that, right?
So I think we could come up with a metadata table name type approach, right? Namespace.view.storage or something. But there's no reason why that can't just be a hey, we go load the table from the views metadata instead, or something like that.
I think the most compatible and most portable solution is a table is referenced as a table and a view is referenced as a view. If you then are saying well, we actually reference the storage through some metadata table or extension or naming, standard or something like that, that gets less portable. And, then maybe Trino doesn't represent it properly and something works in Spark that doesn't work in Trino. So the lowest common denominator is a table is a table and a view is a view.
Yeah, I think the issue with that, I think, is like if you switch from like, I don't know, Hive catalog to REST catalog, suddenly in Trino you're able to like insert stuff into the view, right? That's kind of the thing we don't want to have happen, right?
What do you mean insert into the view?
Oh, like
Insert into
the user could like modify the storage table. Sorry.
I agree with Dan here that like controlling access is a different layer, and I would probably not solve the problem of, hey, user wants to do something weird or dumb by saying we're going to add a bunch of complexity to the representation, because the flip side of that is also I just want my existing table services to run against that, right? I don't want to have to update orphan files to like go treat that differently, or like find paths and know about tables that exist that are unreferenced from the catalog and things like that. So I think it's the waterbed effect of complexity, right? Like if we say, okay, we're going to solve this access control problem by just making the tables reference a different way than any other table, then we're increasing the complexity over on the side of how do I maintain those tables? How do I update those tables? Because I still have the access problem. Who should be able to update that table? How do I reference that table from Spark to do the update? Like then we're just pushing where that problem is. And I think it's, again, like Dan said, obfuscation rather than fixing the access problem. Anton?
Yeah, a quick question. Like, are there any use cases where we want to update both of the entities atomically? Like if you're performing the operation, you want to update both the view and the reference table atomically. And if you don't do that, do you have any issues or something like that? So it kind of goes back to that question. If we represent that as two objects, then are we missing any features, right? Because like it's probably arguable what's like at the end of the day, you still have to be able to write to that table from some process or read from that table from some process. So that's clear. So it like you would need to do that access from those places. But is there a use case where you need to modify or like atomically those pointers? Otherwise, you have some issue.
I think there might be a use case where we evolve the view definition to become like a different SQL completely. Then you need to refresh also the storage table atomically. But I would say that this is an advanced topic, and maybe to start, we don't allow materialized view evolution, but yeah, it's up to others also to see.
Can we address that by dropping the pointers? If it becomes unavailable, can we drop the pointer to the storage table then in that view definition?
But then this boils down to atomic change still.
So I think in what Wall is talking about, let me clarify, because I want to make sure we're talking about the same thing. It sounds like you're talking about changing the view and updating the materialization to match that view at the same time.
Correct.
Because if all we're trying to do is invalidate the materialized version, that just means we need to have the version identifier from the view somewhere in the table materialization, so we can say, hey, this snapshot is it was derived using this SQL from the view, and if that's at version 10 and the view's on version 12, you can't use it.
So that's a property on the table, right? To reference which version of the view is used to derive that table. But then again, to update that property, it's an atomic change on the view definition and the table so that you can update the property. So I think the problem exists inherently. Some way or the other, we have to update both at the same time upon view evolution. But I'm fine with not allowing view evolution for materialized views to start.
So I think that you do have a harder time combining those operations, right? We would need to have some endpoint, like if we were going with a new materialized view object with like a metadata JSON pointer or something, then we could actually have an atomic update of the materialization and the view at the same time, because we're combining the commit process. If they're completely separate commit processes, then today we have basically no way of doing that besides the like multi-table commit stuff. And we have not updated multi-table commits for views, and so like that is definitely something that is a capability outside of what we're talking about. I don't know how many people would do that, because if you need to update the view definition and the materialization at the exact same time, why aren't you just using a table? Like, why is that not a workflow to produce a table and then you can say when you can read that table? Like, I don't know why you'd use a materialized view for that necessarily.
So
yeah,
again,
I would actually say that I'm not convinced that those things need to be done atomically in any situation. I think it comes down to like, what do you consider a violation of freshness? Because there are multiple ways that you can, become unfresh. And if you modify the view, and like if we're storing like, hey, what was the view version that we put, or that we the snapshot in the storage table was created against, if there's a mismatch there, you have a freshness problem. That's, you need to refresh the table. It's the same thing as if you had just timed out in terms of your lag or your freshness guarantee.
I think if we can solve this mismatch problem by strictly properties on the view, maybe we can get away with updating view definition. But if the property is required on the table to reference the view, then definitely we need to handle both in the same transaction. So it depends on the solution how to match the new view definition with the new table, and whether the matching mechanism is on the view side or on the table side.
I think it would be on the table side. So the way this works in my head is your snapshot metadata for the table points to the view and says, I'm at version 10 of this view. And it also points to the underlying tables. So say it's a join. It would say this table reference in the view had snapshot X, and this table reference in the view has snapshot Y, and you would basically need to, validate your freshness requirements from that metadata. One freshness requirement is that if I'm reading the view and using the materialization, the latest snapshot corresponds to that, that same definition of the view SQL.
I fully agree to that. What I'm saying is the property to on the table to point to the view version would need to be updated upon view evolution. So when we're evolving the view, we have to transactionally or like atomically change the.
We would only need to do that if we were updating if we were updating the view and producing a new materialization at the same time.
No, even if we don't produce a new materialization, then the existing table is no longer good for that new view definition.
When we update the view definition, it goes from version 10 to version 11, and then that automatically invalidates using the materialization for version 11 of that view, because the version doesn't match.
So every snapshot in the storage table would have a property on it that tells you I was produced for version 11. If the view loads at version 12 and it goes to load the table and says, well, this snapshot is produced for version 11, this is no longer fresh. Yeah. And so you only ever have to update the table. The view definition doesn't need to change. If you change the view definition, it effectively invalidates all the snapshots that are in the table. So that's a reasonable approach. I'm not saying that's what it has to be, but I'm just saying I don't think that we necessarily need to do an atomic operation across both of them. There may be ways to do this without that requirement.
Okay, sounds good. Yeah.
Ryan, do you want to summarize like kind of what we have and then maybe think through how we can continue this conversation? Perhaps it might be better to do this as a follow because I think live does better than all of the ideas we have plopping around in the message threads.
Yeah, so I mean, it sounds like we should probably just take a bit more time and talk through this. I think potentially, like, it would be a good idea to write down the rationale and requirements, right? So things like we want to be able to hide the tables in the catalog, right? And we want to be able to not hide the tables in the catalog. We want to be able to, you know, eventually, because this was part of the REST discussion, we want to eventually have the option of no longer having metadata JSON files, but we're not doing that yet. So like we have a number of concerns. I think it would be really good to address those concerns and have everyone come together on a list of things like, I should be able to build a system that does this, right?
Who's responsible for that? We should choose somebody to aggregate that so that way you don't have 5 people do it.
Agreed. Jack, do you want to lead that, or Jan, you can lead that? I would say one of you guys, since you're the most active on this. I think then we the step after that would be like, okay, you know, these are our concerns or the things we want to design for. This is possibility 1. This is possibility 2. And I think right now, it sounds like we're talking about 2 possibilities. It's like completely separate objects that use the existing APIs and integration versus a combined object of some kind, like combined commit object. I don't think that what I listed as option 3, which is like a mashup of table and view metadata, I don't think we're talking about that. So I think we just have those 2 possibilities, but then we can go through and say, how would these concerns play out in each of those possibilities? Because I think that's probably where we need to go to make a decision.
Jack, if I remember correctly, you're going to be out soon, right? For a little while on leave?
That's fine. That's just for company stuff. But
okay, got it. Okay, so you'll be available to run something like this if you could.
Yeah.
Awesome. Thank you. And thank you for the discussion. I think we are like closer to like being on the same page and being able to make a decision than we have been. So thank you, everyone. That was a lot of fun too. So awesome. Have a great week. We'll see you guys in 3. Bye.
Thanks, everyone. Bye.
See you.